two different mining methods. So remember, I mean, most of these sites operated before the 1940s. There was zero environmental regulations. You know, modern mining companies are, you know, that they are forced to operate in a much stricter regulatory environment. Of course, accidents definitely do still happen, you know, and it's essential to have very detailed monitoring and regulation to make sure that things are done as well as they possibly can be. But, you know, if you look at the mining methods, for example, I mentioned it was mostly underground in the past. Now, companies are mainly using open pit mining. And so these tend to be much larger operations. And so visually, you know, you can see the pictures, historically, I mean, there was some waste on the surface, but the scale of the operations, you know, today, they do tend to move around a much larger volume of material, in part because they're using a different mining technology and the grades of the ore deposit are low. So that results in relatively smaller volumes of waste rock for the new mines relative to what you would see from a large open pit operation. The milling techniques in the past, you know, I've already talked a lot about those. Today, what's used, for example, at Moose River is ball milling, gravity circuits, where you're just separating, you know, things by specific gravity, and then also the use of cyanide. But, you know, a major difference and a very important one is that, of course, way back when, you could just put the tailings in where you wanted. You know, they just discharged them directly into lakes, streams, and the ocean. Today, those tailings need to actually be stored in engineered impoundments, or there has been proposals to store them in mined-out open pits in the future that are still under consideration. And then there was no treatment of mine tailings and effluent in the past, whereas today, you know, the companies are required to treat, to remove cyanide, arsenic, and iron, and you know, they are required, and they're certainly supposed to be doing as best of the job that they can, and they're subject, you know, to monitoring and you know, so there is treatment, unlike what has happened in the past. But again, like I said, you know, accidents do happen. These are large industrial sites, and it's imperative that you know, everybody sort of play their part to try and work together to minimize the impacts of these operations and make decisions, you know, that balance, you know, the economic benefits of these sites with, you know, things like the ecological benefits and the social benefits to local communities. So if you look at, just to give you some sense of, you know, the scale of these operations, you know, this is an air photo of Moose River in June 2012. And so most of the historical mining happened sort of over in this area of the diagram over here. And, you know, these were mostly underground operations. They're not that easy to see from the air. I mean, you know, these are old operations, and so Mother Nature has really overgrown these areas. But, you know, just for reference, I mean, if you look at the same air photo today, or in June 2019, you know, you can see, I mean, these sites do operate at a much larger scale. So in this case, this is Atlantic Gold's Tukloy mine, the open pit up here on the upper left. Here's the mill site and a big waste rock dump. This is the engineered tailings impoundment that's shown right here. And one of the things you'll see referenced as well is the company, of course, like, you know, most gold mines in Nova Scotia are operating where there was previously gold mining in the past. And so what they've actually had to do is remove some historic tailings that were contaminated with mercury that in the past, of course, were just discharged into rivers like this. And they've actually put them in a lined containment cell within the engineered tailings impoundment. So the water from this tailings impoundment now it gets treated at an effluent treatment plant, primarily to remove arsenic. That generates also a bunch of material that sort of suspended sediment that's supposed to get captured in what are called geotubes. And then that water is discharged to a polishing pond, ultimately to a constructed wetland. And this ultimately is the discharge point to the environment, in this case to Scraggy Lake. So, you know, again, these are fairly large sites, and you can see, you know, that you know, with modern mining technologies, you know, there's a significant amount of land disturbance, and the key difference being as well that, you know, ultimately for a mine to be permitted these days, these companies also need to have an approved reclamation plan to try and return as much of this land as possible, you know, to some semblance of its original state that could see a secondary reuse as well. So these are some photos I took during a tour of the Tukoi gold mine with some provincial and federal regulators in December 2018, just showing their open pit operation, the processing plant where they use cyanide to actually extract gold from the crushed ore. This is sort of just a panoramic of the tailings impoundment, and these are the geotubes I've mentioned. And then finally, I'm running a bit over time here, so I'm just going to wrap it up in the next couple slides. The key messages I want to pass along here is, unlike like in most historical districts, the best place to find a new mine really is in the shadow of an old mine. That's an old saying in the mining industries. And what that really means is that even though modern mining companies are not using mercury, for example, to separate gold from the ore at these mine sites, it's not improbable that they could have legacy mine waste that do have high arsenic and mercury concentrations. And so it's imperative really to do these sort of baseline studies, understand where these materials are, and handle them as carefully as possible. One of the things that's also been mentioned a little bit, and also in the media is just, about the potential environmental impacts. One of the things we don't see a whole lot of at Nova Scotian gold mines is actually acid mine drainage. And the reason for that is there's a lot of carbonate minerals like calcite around. And so the mine drainage from these sites tends to be close to neutral. So acidity can be an issue in some areas, but generally in our research on hundreds of samples from districts shows it's mostly close to neutral, but these waters frequently contain high concentrations of arsenic. You can reprocess some historical mine wastes to reduce environmental impacts, and I think more of that has to happen in the future, but there are a lot of regulatory and policy barriers and new technologies that need to be developed. So there's ongoing work on ecological impacts of mercury that still needs to be done, and we still need to better understand the long-term performance of things like waste rock, open pits, and tailings covers. So I'll leave these slides in the presentation. You can look at the recording later. There's some excellent work on ecological research that's underway and being led by Dr. Linda Campbell at St. Mary's University. By she and her students, we published a recent review of ecological mercury and arsenic bioaccumulation in some of these districts in 2019. And one of my own colleagues, I mentioned the idea of extracting value from mine waste, and we've got a huge program at Natural Resources Canada where we're looking at exactly that. How can we use historical mine waste that might have valuable elements and extract that material to produce them into a more benign product? So ultimately you extract a valuable element like gold or cobalt or other elements and end up with a product that you might be able to even use for things like concrete or making bricks or other things. So that's a link to a much longer talk. Well, it's probably getting the same length as this talk, I apologize, on gold mining in Nova Scotia. I gave you the Atlantic Geoscience Society, a YouTube link to that talk. And finally, I promised I'll end on this slide here. What can you do to help? A huge part of dealing with this increase in demand for metals, whether it's here in Nova Scotia or globally around the world, is that we all need to play our part to reduce, reuse, and recycle metals. And so, here at our house, we're a family that uses a lot of Apple products, and unfortunately, I really like Apple as a company, but they are also experts in planned obsolescence. They always want you to have the newest and latest, iPhone or iPad or other things, and so before you run out to the store and buy, a new phone, consider, do you really need that upgrade? Or could your old phone be repaired? Or if you're gonna get something new, don't just throw your thing in the garbage, your old phone in the garbage. Donate it for reuse. Perhaps a senior's home might really be able to use that, or somebody that is living below the poverty line that could really benefit from reusing that device. So we don't see these things, that they have a second and a third and a fourth life. Where you can, purchase electronics from companies that have published supplier responsibility standards, that are keenly aware of things like human rights and the environment and worker health and safety. Some companies are much better than others, and sometimes you get what you pay for. If you buy the cheapest thing off Amazon, these are often some of the products that have the biggest environmental and social footprint. If you really do want to recycle things, whether it's your phone or your laptop or old peripherals from your computer or what have you, there's an excellent program here in Nova Scotia. You could go to recyclemyelectronics.ca and prevent your electronics from ending up in landfills or being shipped to some place overseas, to be picked apart in places like China and other locations where, there are high environmental risks. And then the final point is, for those of you that are active and that are very well aware of recently proposed mining projects, I'd really encourage you to participate in the environmental assessment of these projects through the Impact Assessment Agency of Canada. There are, as I mentioned, several projects that are currently under consideration right now. There are funds available to various organizations to participate, and the more information, the better, when it comes down to making these decisions. The public, whether you're into sports fishing or you're a resident of an area, that sort of, local knowledge of the environment and its ecology and on all these sorts of things is a really absolutely essential part of actually making informed decisions as a society, on the future of mining projects, here in Nova Scotia, elsewhere across Canada and around the world. So if you're interested in this topic, you want to learn a whole lot more and you want to hear from, folks other than myself, this is just a plug for a really interesting UNESCO lecture series that's going to be starting actually on January 26th. I'll leave this in the recording. You can sign up for that. And finally, there's other organizations that are really thinking outside the box, like Mining Watch Canada, for example. We've worked very closely with them, in some of our past sort of working groups at Natural Resources Canada, and they really have come up with some unique ideas and got people together, to think about how do we deal with these challenges and find new opportunities for addressing, an increased metal demand while also looking to decarbonize, our society. They had this excellent conference last year called Turning Down the Heat. Can we mine our way out of the climate crisis? And so this final report and some online resources, are really excellent food for thought when we want to think about, providing resources for a much more sustainable future. So I'll leave it there. Apologize for running a bit long this evening. I hope that, perhaps sharing that opens, sort of some new perspective and generates some new thoughts, on some of the challenges that we all face in trying to make the best decisions possible in terms of developing metal resources in the future. Thank you very much.
Thank you.